All right, I want to welcome everyone. Thank you. Oops. Let me fix an audio issue here. There we go. Welcome everyone, both joining here at the Wisconsin Energy Institute, and welcome to those joining through Zoom. We're excited to have you here. If this is if this is your first time joining us, we appreciate you. If you're a repeat attendee of the Forward in Energy Forum, we're glad you're here as well. My name is Scott Williams. I'm the education manager here at the Wisconsin Energy Institute. For those who are not familiar with the Wisconsin Energy Institute, our mission is to provide leadership on campus for multidisciplinary research, education, and outreach efforts that accelerate our transition to clean energy systems and solutions. And so the purpose of our Forward in Energy Forum, which is a monthly series that we host here at UW, is to bring together experts both on and off campus to talk about important technical, social, political, and economic dimensions of a wide variety of clean energy innovations and topics. And so today's forum focuses on a recent resurgence of interest in nuclear energy, both among business as well as government leaders in the state of Wisconsin. And our panel today will discuss the implications for fission and fusion technologies in our state's energy future. But before we get into today's session, do you have a few announcements? So first, as Native American Heritage Month begins in a few days, we do want to acknowledge that the land that WI occupies, as well as all of UW-Madison, is the ancestral home of the Ho-Chunk people, who have called this land Dejope since time immemorial. And we recognize and respect the inherent sovereignty of the Ho-Chunk Nation and the other 11 Native nations within the boundaries of what we now call Wisconsin. And we encourage you to take time to learn more about and support the efforts of tribal nations in Wisconsin beyond leading the transition to cleaner and just energy systems. Next, want to highlight our next Forward in Energy Forum, which will happen exactly 2 weeks from today, so a little bit earlier than our normal schedule due to the Thanksgiving holiday. So on November 11th, our title is Land and Producer Perspectives on Land and Resource Utilizations. And we'll hear from a lot of farmer perspectives on how they make the most of their land and other resources with the goal of optimizing farm yields, profits, and sustainability. You can go to our website, you can see the QR code, or you'll see the link in the chat to go to energy.wis.edu to register for that event. Finally, a couple logistical notes. We'll have opening remarks from our panelists, as well as some Q&A with our moderator before taking audience questions. If you're joining through Zoom, you can use the Q&A box to submit your questions. If you're in the room, raise your hand. I'll come around with a microphone. You can ask your question that way. And if you're in Zoom and you need live captioning, you can click on the Show Captions button. And any other technical issues in Zoom, feel free to write it in the chat. With that, to introduce today's topic, to set the stage and introduce our panelists, I'm pleased to introduce Professor Paul Wilson. He's the Granger Professor of Nuclear Engineering, as well as the chair of the University of Wisconsin-Madison Department of Nuclear Engineering and Engineering Physics. His research interests focus on developing improved tools for computational modeling of complex nuclear energy systems with applications in radiation shielding, nuclear waste management, nuclear nonproliferation, as well as energy policy. And in addition to his group's research, Professor Wilson has served in a number of advisory and consultant roles for government and research institutions, as well as nonprofits and companies. So we're grateful for him to help set the stage and introduce our panel today. So welcome.
Thanks, Scott, and thanks everyone for being here. It's a pleasure to be the moderator of this session, and obviously nuclear energy is a topic that's been a passion of mine for a long time, as you can probably guess from my career path. So it's exciting to have this panel here to talk about the different topics here. I think that the timing of this is clear, that there's a rapidly growing interest in nuclear energy here in the state of Wisconsin. Thanks to Senators Bradley and James, Representative Stephan, Sortwell, and my own Representative Subeck for the work that they've done so far in advancing legislation, and I think there's more to come. And so I think that's one of the reasons we find ourselves here today to have this conversation, is to really explore where is Wisconsin going and what are the opportunities for nuclear energy in Wisconsin. It's an important part of a growing conversation about the state's energy future. As someone who's been keen to have dialogues about energy and nuclear energy in particular, I've long lamented that energy has kind of been off the political radar screen in the state for some time. And so it's exciting to me to see it coming back as we see a lot of new opportunities emerging, It's clear that it's important for the economic development of the state. And so it's an important topic for us to be grappling with the energy picture broadly, and of course, the role of nuclear energy within that. And I think our panelists today are going to have some insight in all of those different aspects. Since there's nobody here from UW-Madison other than me, I'll maybe sort of give a brief insight into what our department does. We have a unique nuclear energy portfolio here at University of Wisconsin-Madison, with a unique balance between fission and fusion energy research, and a long history of doing important things in the fission and in traditional nuclear energy space, but also a growing prominence, as you'll hear from one of our panelists, in the emerging fusion industry, and looking forward to how that emerges and allows Wisconsin maybe to be a center of gravity nationally and internationally for fusion energy development. We have a lot of great facilities here where we do contribute to both fission and fusion energy research, and a lot of great faculty doing exciting things, working with many of the companies around the country and around the world, as well as the national laboratories, and advancing both in the computational space, the experimental space, and the theoretical space. As a last comment, maybe not everyone here may be familiar with what nuclear energy is. There's basically two options. You can have fission, where we take heavy elements and break them into two and release energy according to Einstein's famous formula. Or we can take light elements and bang them together and combine them into one, and again release energy according to Einstein's famous formula. We're blessed to have a nuclear physics world where you get energy out both ways. So it's a good thing. Ultimately, that energy gets turned into heat one way or the other, and that heat will boil water and turn a turbine and ultimately get electricity. And that's the way that we expect fission to work today and fusion to work, at least at the beginning. If there's more inventive ideas that people have, but certainly for the first generation or two, it'll be largely the same thing. So that's the technology we're talking about here. And with that sort of introduction, let me briefly introduce our panelists. So furthest from me at the far end of the table here is Senator Julian Bradley, who represents, I don't know the district number, but a district just west of Milwaukee, I think, and has been authoring some of the legislation and chairs the committees in the Senate that oversee a lot of the legislation and policy that's coming out. So we're happy to have him here. Next in the middle is Kevin Nort. He is the Executive Vice President and Chief Strategy Officer of Dairyland Power Cooperative. And importantly to me, he's an alum of our department. And so he has some experience in the Pacific Northwest in the energy industry and has been back in the Midwest now for a few years. And then closest to me is Rob Hughes, the head of external affairs for Realta Fusion, one of the 3 fusion companies that we take credit for here in Wisconsin that are connected to University of Wisconsin, and one that does its research right here on campus. So with that, I'm going to hand the mic down to Senator Bradley. Get this one going here. Each of these panelists will have an opportunity to give, 5, 7, 10 minutes worth of remarks, and then we'll transition to Q&A. So please, Senator Bradley.
Sounds good. Thank you. And good afternoon, evening. It's hard to tell with the sun setting earlier. I don't know. Welcome. How's that? I am Julian Bradley, State Senator for the 28th Senate District in southeastern Wisconsin, Waukesha, Walworth, and Racine counties. I am the chairman of the Senate Utilities Committee. So it's a Senate Committee on Utilities, Technology, and Tourism. And I know by everybody's reaction, clearly you see that all 3 of those things go well together perfectly. And that leads to why nuclear energy is so important, right? I'll just kind of try to segue into why tourism fits by just throwing it out there that we want to make Wisconsin a destination for nuclear energy. There we go. But the reality is it is what we want to do. So I've been in the Senate. I first got elected in 2020, so I started serving in 2021. I just got reelected in 2024, and I've been honored to chair that committee, the Senate Utilities Committee, both of these terms that I've been in. Nuclear energy, from the time I got here, started to be a little bit of a topic of conversation. So today in Wisconsin, we have divided government, as everybody's likely familiar with. We have the Democrats control the governor's mansion. Republicans have both the Assembly and the Senate. So we have what's called divided government. However, for the first time since I've been even politically aware, I realized that you could talk about nuclear power and the immediate reaction, regardless of what political party you were with, wasn't, oh no, don't touch it. It wasn't radioactive, if you will. Instead, people were willing to engage. They started to understand that, Wisconsin's starting to lag a little bit, and that maybe it's time we start opening up that conversation. And so that's what we did. A bipartisan group of us started talking about nuclear energy from 2021, 2022, and on and on. And we finally got to the point we started calling in some of the experts. And we brought everybody in and we said, what is it going to take to open Wisconsin up to let everybody know that we're open to nuclear energy? You see, we get all 4 seasons here. We're one of the few states that gets all 4 seasons, but we get the extremes, right? In winter, it gets really, really cold. And in summer, it gets really, really hot. And we are net importers of energy here in the state of Wisconsin. So we need an all of the above approach. There's not an energy source that we can afford to say we don't want it. We need all of it because we don't produce enough within the state. So we have to buy it externally. So we started posing these questions and asking, how can we do it? What does it take? And as most of you that are familiar with nuclear energy know, it's regulated heavily at the federal level. There's not a lot at the state level, but there are a few things we could do. And one of, if not the most important thing that we started off this session doing was we did a resolution. And this resolution just simply stated that Wisconsin is open to nuclear energy and adding it into our portfolio in a larger scale, and that we're going to start taking steps to make sure everybody understands that this is necessary. And it was super bipartisan. You mentioned your Representative Subek, who was a great leader on this within her caucus. And so we were happy to see this pass the way it did. And myself and Representative Steffen and Sortwell started talking about what other steps can we take. So we started, again, including the experts, because I will promise you I am not an expert. If you have a technical question, I hope it's posed to one of the other people here, because I won't be able to answer technical questions, but I can certainly answer legislative questions. And that's how we started formulating some of the bills. And I know we'll talk about some of that legislation, but we were able to not just formulate them, but we got a call from the governor's office that said, we're interested. How can we work with you on this? And we passed a couple of really important, the first legislation really geared toward nuclear energy in over a decade here in the state of Wisconsin. Overwhelmingly bipartisan. There's a huge level of excitement. And it's a lot of fun to be able to talk about because everybody really understands this is the future. When you talk about AI and you talk about the demands on energy and all of the things that we want to power for our economy, you can't do it without starting to talk about nuclear energy. So I'm very excited to be a part of this. I appreciate the invite to be on the panel as a non-expert. And I'm excited to answer your questions as well.
Great, thank you very much. Next, we'll hear from Kevin Nort.
Okay, so Kevin Nort here, as Paul said, alumnus of the nuclear department. I was a grad student here, and it's great to be back in Wisconsin trying to advance the path of nuclear energy. So myself and my company are super excited about that. I work for Dairyland Power. I'll tell you just a little bit about them to kind of set the stage. But first thing I'll tell you is Dairyland Power and Wisconsin as a state, has been nuclear pioneers. Not only did they build a great department, but one of the earliest experimental reactors on the fission side was the La Crosse boiling water reactor designed by Alice Chalmers, and it was a Dairyland plant that ran for a good number of years. We're headquartered up in La Crosse, Wisconsin. We're a power supply and transmission company. We've been around since 1941. We serve in 4 states, Wisconsin, Minnesota, Iowa, and Illinois. We have primarily served in the western portion of Wisconsin, but our plans are to grow and power a thriving Wisconsin as well as the upper Midwest economy. So we have actually now got some power supply customers over in eastern Wisconsin as well as down in southern Illinois, and we're looking to keep growing and growing and growing. That's good for us, good for the state, good for the region. So as we grow, the question becomes then, how do we power that growth and where do we go from here? So right now, our growth is looking to be substantial. That's a good place to be. And it's a lot different than what's been there in the last 10 to 20 years. Over the last 20 years, I've been in this business a little over 35 years and, kind of see the various cycles. But since about the early 2000s, most folks in my type of role at the energy companies have been worried about flat or declining load. It's kind of like load's never going to grow again. It does, the economy isn't as electric intensive. That has really changed. So for Dairyland, we have potential data center customers coming in, of course, electrification, and then just what we'll call organic growth. The state of Wisconsin, whether out in the Milwaukee area with some of the gigantic hyperscalers that are coming in that were my customers. Several of the key ones were my customers when I led a company back in Washington. But that's great. And here in the Madison area, right, there's data centers and then just growth everywhere. I come down to Madison and there's always cranes and everything. That's leading to increased energy demand. So how do we do that, especially when folks want a reliable grid, an affordable price of power, and customers by and large are seeking to have decarbonized power? Advanced nuclear really fits the bill for this. So it's a tremendous opportunity, kind of once in a generation or more type opportunity. So with that, we are seeing all this demand, data centers being the biggest piece, but you are seeing electrification of vehicles, moving to electrification of building heat and other systems. That's creating some challenges just beyond the normal supply and demand. There's certainly demand is outstripping supply. It's really hard to get your arms around where demand is going to be because there's a lot of potential double counting and sort of bragawatts type of stuff. Is it all going to come? But even if you take the forecasts or press announcements and divide them by a factor of 4, it's still pretty substantial. So no more flat or declining load. How do we catch up and get back into developing resources is really the question. As we see this demand growth come, it is putting pressure on not just summer peaks, but we're also starting to see shifts to winter peaks. So as the senator said, really cold in the winter, really hot in the summer. Renewables have a big role to play, but they're not going to do it all. A lot of the fossil plants, despite any environmental type perspectives on them, are aging and near the point of retirement. So how are we going to do this? And how are we going to do this in a way that doesn't put an additional burden on an already very strained gas grid? And so as we see our region move to be a bimodal peaker, peaking in the summer or winter, or maybe even a winter peaking, advanced nuclear is very well poised to come in, provide that dependable, clean energy and capacity that can make Wisconsin thrive. As we look forward and we step back and look at Wisconsin as a state, again, as you had said, we're an energy importer, so it would be nice to perhaps be balanced or maybe even be an exporter. But when we look at the size of the demand in Wisconsin, and we think about what are some of the opportunities with advanced nuclear, bringing in very large scale AP1000 plants, which are great machines and all, but that is a big bite. And advanced nuclear, specifically the SMRs that come in much more manageable chunks, say, for example, the GE Hitachi BWRX 300, that's a 300 megabyte, or X Energy or Natrium or something. These are modular, scalable, and so they are a very good resource alternative where we reduce the risk of stranded investments. The development time is likely quicker, and they can sort of be placed in service along with demand growth. So that takes a lot of risk off of the energy companies who ultimately pass that on to the consumers, which is a good thing. And I'll just wrap up with sort of call to action. While there is a ton of demand growth and things are looking pretty rosy, to quote the old song, study nuclear science and, future's so bright, you got to wear shades. We don't want to just count our chickens before they hatch. While there's a lot to be excited about, it is not an inevitability, okay? Electricity is a fungible commodity. We have to recognize that. The nuclear industry has to get moving to compete with this growth. The rest of the world isn't standing still. Supply traditional resources, renewables, they're out there trying to come. We've got massive interconnection queues all across the country. In MISO, where we're at, the Mid-Continent Independent System Operator, the interconnection queues somewhere north of like 300,000 megawatts. A lot's renewables, a lot's gas, whatever. But we're also seeing things like large-scale transmission. My hat is off to MISO. I think they're the best in the country at doing this, and Dairyland is proud to be a major player in some of the large-scale 345 and 765 projects that will be developed. Virtual power plants, which may be a new concept to some, but it is a real workable resource. California's deployed about 500 megs that got them through recent peak periods. Distributed energy resources, curtailable service, where a big data center may agree to be curtailed up to 50, 100 hours a year. That can make a big difference because you're playing at the margin. These are things that are all happening, and nuclear energy has to organize itself and position itself so it doesn't get outcompeted. This is not really a technical issue. It's really an industrial policy, coordination, finance type issue. The technologies are sound. We've got to gain our skills again at building big things, figuring out ways to finance these where the interest costs aren't going to crush you, and move forward. So mature industries tend to have 2 or 3, 4 at most competitors. We're not in a mature industry right now with advanced nuke, but as we're heading that way, I think it really is going to come down to we need to focus on the most promising alternatives and get organized to increase the coordination and efforts to bring these to bear. So I really applaud the senator and others here in Wisconsin, because Senate Bill 124, 125 are big steps to move in that direction. If we just sort of say the marketplace will sort it out, we're probably not going to get where we need to get. And Dairyland is, when we say advanced nuke, we're open to both fusion and fission. For us, we're looking for the best, dependable, cost-effective power resources. So thank you.
All right, Rob, you're next up.
Hi, everybody. Thanks for having me. So I am here to represent the fusion industry. So I am the head of external affairs at Realta Fusion. We are a University of Wisconsin spin-out company, originally funded with some Department of Energy money. We are working on sort of the opposite side of the atomic energy coin from what folks are maybe more familiar with, so the fission side. Essentially, I mean, as we mentioned, right, this is the idea of combining these lighter atoms and forcing them together. Take your E equals MC squared, you end up with a bunch of energy that comes out of that reaction. And, you know, for folks who may be somewhat familiar with fusion, there are some ways of doing that. The tokamak is a shape that people are probably the most familiar with, and essentially it's a big donut. So you have a hot gas, a plasma inside of that donut shape. The problem with that is that once you build it, that's about as big as it can get, right? So you can't scale that up in 3 dimensions. What we're trying to do is something that we call the magnetic mirror, which is a long cylindrical device. And what that allows you to do is essentially bounce ions back and forth and kind of mirror them back and forth across this linear shape. And essentially you can make it as long as you need to. You can snap on additional modules to it so you can get to more power output. And the reason that that's significant for us is that you can sort of play in a lot of different customer spaces, whereas the tokamak might be a big 350 megawatt device, really better suited toward either like a massive data center or a grid tied application. We can go anywhere from as small as a 50 megawatt. So that's like a remote mining operation, could be a chemical plant, pulp and paper on the small end, all the way up to grid scale, about 500 megawatts for our device. So, while I won't ask Kevin to get his checkbook out yet, we don't necessarily have to get to grid scale as our first market customer in order to be successful. We can play in a much broader customer space. Backing up a little bit to kind of the formation of the company. So as I mentioned, we were a University of Wisconsin energy spinout funded by DOE. I joined the company about 9-10 months ago. I'm an East Coaster. We are much better than you Wisconsinites about bragging about ourselves. Wisconsin does not do a good enough job bragging about the amazing resources that it has. The University of Wisconsin has 4 or 5 working fusion experiments. That is unprecedented. You won't find that anywhere else, right? MIT and the University of Wisconsin are the 2 dominant like nuclear engineering and plasma physics programs in the country. And we're blessed to have a working reactor down in Stoughton that was put together by some professors and some private sector folks. So, we've been able to actually do fusion experiments and figure out how these devices work compared to some of our competitors who sort of have ideas of what their reactors are going to look like and how you might design them, but they don't have a working plasma. So it puts us at like an incredible advantage compared to some of our competitors. And, I just think, the fact that the 4 of us here today are on the same panel is kind of significant, because when I think about how you make fusion real, it takes a lot of different types of people, right? We need the academic researchers. We need the commercial folks. We need utilities who understand how we're actually going to connect these devices. And we need policymakers who can help make it real, right? Like, all of this is such a huge challenge. No one company or one group of people can do this on their own. So it really is a collaborative effort. And I'm looking forward to, getting into all the details of like how we can work together to make this real. But I think one thing that, if you can remember from today that I'd like to say is, I won't ask who the oldest person in the room is or the oldest person is on the phone, but for every single person who's listening today, your entire life has been dominated by this idea of like sucking hydrocarbons out of the ground and burning them up and taking all the economic activity associated with that and sending it to like some shareholder's pocketbook, right? Like, in the future, when we have fusion power plants, we're going to talk about making machines again. These are replicable devices that we can continue to build. We can get this country back to making machines. And Wisconsin, again, to brag out about Wisconsin on y'all's behalf, I should say my behalf as well, now that I'm a Wisconsinite, this is one of the only places in the country where we can make these kinds of machines. We have the supply chain partners, we have the university expertise, and we're starting to see private capital flow into this. There is advanced manufacturing, there is refining, there are just trades in Wisconsin that do not exist all over the country. You couldn't build a company like this in Tulsa. You can do it in maybe 1 or 2 places in the country, and the Great Lakes region is one of those. So I think it's this huge opportunity for us to take advantage of this natural intellectual capital we have and this history of building things in this state and supercharge that into the future. And in the results of that is sort of, if you talk about building these machines here and exporting them globally, we're talking about devices that can bring billions of people out of poverty, right? Like, everybody in this room today lives a standard of living that is unfathomable to 2 or 3 billion people on planet Earth right now. And when we shift to a mindset where we're thinking about energy abundance, what can we do when we have energy abundance? How can we export that globally? Just think about the human capital that you're going to unlock and the things that we can do 100 years from now that we can't even imagine. And we like to think that fusion is going to be a huge part of that. So just super excited to get to know you all, and just very, very excited to see that people are enthusiastic enough to come.
All right. Thanks, all of you. That was a great setting the stage here. So now is a good time for questions. I'll remind the online audience that you have a Q&A button you can choose, and you can pop up questions there. And if you like somebody else's question, you can upvote it and decide to make it a higher priority question. I'll be monitoring that and share those questions with our panelists here. While that's happening, I want to dig into one thing that you've all touched on a little bit, and maybe I think there's more ground there, but what makes this particular moment the moment for having this conversation? From a political point of view, let me start again. From somebody on the inside of the industry, I've been seeing this change for 10, 15, 20 years, ups and downs and things like that, hoping for the conversation to happen. But in the last couple of years, everything's really, there's been catalysts that have really changed the conversation. I wonder, if you can dig in more to this sort of catalyst question, right? You've all talked a little bit about why now, but is there something that's really caused a big pivot that means that now's the time, and there's a sort of a policy side, a business side, and maybe a science side that's part of that. So maybe we'll go back the other way and pass the mic back that way.
Sure. So for us on the science side, So the magnetic mirror as a device was one of the kind of preeminent ways that we thought we could do fusion back as, 50, 60 years ago. When there was cheap gas emerging in the early 1980s, we decided that it wasn't that important to invest in anymore. So the magnetic mirror kind of got put back on the shelf, and all those research dollars went basically just into tokamaks. And so one of the things that had been holding the magnetic mirror back as a concept was that we didn't have magnets that were strong enough to create the fusion reactions that we needed at the time. Fast forward to now, there are high temperature superconducting magnets and companies that make them across the globe. There's a handful of them that have the magnetic field strength that we need to do what we need to do. We couldn't do this in the 70s or 80s. And now we have magnets on this machine down in Stoughton that when they're at full strength, the magnetic forces are essentially like what you would experience if you went to the Marianas Trench and then went 40% deeper into the earth. That magnetic field strength is how we control our plasmas. That didn't exist until 5 or 6 years ago. There's a company in Massachusetts called Commonwealth Fusion Systems, and they build these magnets that are on our device. And that on the technical side has enabled us to do something that was just not possible 20 or 30 years ago.
Okay, I'll talk about maybe 2 or 3 things that kind of conspired to be the combined catalyst. So from someone in the energy supply industry, we've seen over the last 5, 7 years, a definite change in public perception, not just with nuclear power, but just in general. And I'll refer back to some work that was done around hydropower out in the Northwest. So I spent a lot of time in my career around giant hydro, which is a wonderful resource. It has some impacts, but net is a real positive. And there was a lot of pushback against it, et cetera. And what we were finding is from a generational perspective, and we were seeing the same then with nuclear power, was the climate concerns and those types of things were being looked at by generations coming up in a different way, where there was a lot of folks that digital natives that have grown up comfortable with technology and such. And well, hey, we need to clean this up. We need to do a better job. We don't want to lose the benefits of our standard of living coming through a reliable grid. Hey, if nuclear power or hydropower or whatever can do this as a technological solution to the climate issues, among other things, let's get behind that. And that is a big, big change. When I first entered into the industry in the, say, late 80s, the perceptions were much, much different. So I think that's a big piece of the catalyzing. The recognition that we probably allowed as a country the globalization and outsourcing of key manufacturing areas to have swung too far, and realizing that there are national security issues and concerns that we've left ourselves perhaps a bit vulnerable. And what we saw coming through COVID with snarled supply chains, et cetera, I think is another drive here. Let's start onshoring certain things. The idea of national champions in different industrial sectors is now in vogue, where even 4 or 5 years ago, that would look to be, well, that's passe. Industrial policy, that sort of stuff doesn't have a role here in the United States. So you take that public perception, you put it together with the national champions, openness to industrial policy, a desire to reshore and power, retool America to manufacture. And the last thing that I will put together, it's a little bit to my last point, is a key industry that we want to have a national champion is winning the AI race. The AI race is going to require a huge amount of electricity to be able to accomplish that. So given what are extraordinary demand growths, there are things that I think we will certainly meet. What sounds like extraordinary growth now, if we look back to the 1950s and into the 60s, we dealt with these type of growth rates, compound average growth rate, annual growth rates through that period when America was electrifying. So we're not used to them. They are solvable problems. They won't be easy to solve. But to me, the catalyst cocktail is the extreme demand growth, the national security issues, and the change in public perception. Together, they create a very favorable climate to support advanced nuke.
Excellent. It's been said we don't brag enough here in Wisconsin, so I'll agree with everything you said, and then I'll just add in me. I got elected in 2020, and in 2021 and up to today, we've been able to push a lot of these things. But I'll go to public perception is really from a policy standpoint. What I see, this is no longer a toxic or radioactive topic, right? You can have a conversation and people don't immediately worry about meltdown. They say, yeah, that's a good idea. We should be taking steps forward. We would like to see our rates lowered. We'd like to be able to go into the next generation for our economy. And as we talk about AI and we talk about some of the other things that are trying to come to Wisconsin, and as you said, we want to be national champions in this space, we have to find another power source. And so in the Capitol, even really 3 years ago, you still couldn't really have a great conversation on nuclear. It was still very, boy, I don't know, let's look into it. We'll talk. And now we're excited about it. And I really think that has to do with public perception. And I want to give all of you credit for what you've done in your industry and anybody else that's involved in the industry, because you haven't stopped talking about it, right? Just because policymakers weren't interested in moving forward didn't mean the research didn't stop. The work didn't stop and the education efforts didn't stop. And that's why we were able to do what we've done. And we're excited to keep going forward.
Just a quick follow-up. So how did you personally get excited about nuclear? Was it before you got elected, or was it something you learned about as a new senator?
Yeah, it was The Simpsons. But no, it really getting into the Utilities Committee and really taking a look at how we need to power our state. As soon as you realize that we are net importers, if you're a fiscally conscious person, you go, well, that's a problem. So how do we change that? We want to at least be self-sufficient, if not exporters in some way. And from there it was, okay, how can we make up that deficit? And then why aren't we moving forward with nuclear? We just have the one plant, the two plants technically, I guess, over in Representative Sortwell's district. But what's stopping us from expanding, and then talking to other people and saying, what do you think, and building consensus?
Great, thank you. Another question I guess I have, Kevin said earlier, this is not inevitable. Nuclear is not inevitable. What are the futures look like that don't include nuclear, right? Either because nuclear can't meet the challenges that Kevin's laid out, or because, the states doesn't become attractive enough to people. What do you see the future being then in a future without nuclear energy in the state of Wisconsin?
Expensive. We have high rates as it is, right? Across the board in every industry, due to inflation, we're spending a lot of money. I believe nuclear isn't just the future, but I believe it's essential. We've got to find a way to make this work, because the people that hired me, my constituents in the 28th district, are counting on us and counting on all of you to find ways to make sure that we can get nuclear up and running. If we're going to be the economic driver in the AI space, if we're going to be innovative, if we're going to be the future and forward-looking state that we hope to be in this space, we've got to get to a point of self-sustainability, and I just don't see any other way to do it without nuclear. So it's one of those, to your point, it is not inevitable. We're going to have to work towards it. And it's going to take a lot of work, but I think there's a lot of people that are invested in making sure we get there.
Yeah. And so when I had said, nuclear is not inevitable, it really comes down to a saying I use all the time. I have on the whiteboard in my office, and I started using it around industrial safety because I care about the people that I lead. But it's true in any business setting as well. And that is complacency kills. Okay. People get injured in the electric power business or many other industries, usually not on the big complicated evolution that is all planned out and everybody's all keyed up for. It's the routine stuff day after day. They get complacent, right? One of the things that I try to champion with advanced nuclear is there is a lot of promise. There is a lot of demand growth. That is really good. But let's not just assume there's no way they can get by without us. And I've seen that. I've been lots of advanced nuke conferences and, work with many people in this particular sector. And you'll often hear, there's no other way than nuclear or something. It's like, let's look at Andy Grove, if people remember him, the old CEO of Intel. Only the paranoid survive, right? So how do we make this happen? I think this is very likely. I think there is an extremely strong economic and technical case for advanced nuclear. I'm very bullish on it. I don't think it's just going to happen by itself. When we look at any particular technology, the technology may be great. Where's the workforce? What is the licensing paradigm? What are the early stage risks and how do they get spread? Because if there is a situation where, whether it's my company or some of the other energy companies here in Wisconsin, are we going to take a bet the company risk if it's really uncertain? Probably not. There's ways to syndicate that risk, build partnerships, work with public policymakers. So I come back to, we can make advanced nuclear a reality. It can thrive, but it is going to take more than just saying demand is growing. We need to understand what the competition are. That gives us price points that are effectively our bogey. And we've got to reverse engineer reactors to meet that. We need to understand what the actual demands on the grid are. We're talking about in data centers, things like asynchronous loads and a whole lot of asynchronous, not to get too wonky, asynchronous resources, right? Having spinning heavy machines out there is a positive thing. Understanding where the nuclear can fit in is going to be important. And then organizing across all these sectors to say, and it doesn't have to happen at the national level. It'd be great if it did. But if we can organize at the state level, how can we move this forward? Otherwise, we're going to be wrestling with the classic chicken and egg problem, and other solutions will be found. Let's stay hungry, get aggressive, and make this a reality.
Yeah, I'll let you into my nightmares real quickly here on the it's not inevitable point. Yeah, super not inevitable, right? Like we are going to need to raise about $2 billion ish to do what we need to do, right? So from a yes, our company, yes, the globally, yes. I mean, we're talking like tens of billions of dollars, right? Like a $10 billion injection of federal funding would be really meaningful. But our company alone will probably need to raise about $2 billion all told before we're off and running. So there's the money, right? Private capital investment is going to be huge. There is the workforce, right? Right now, the workforce for fusion is a lot of egghead plasma physicists and nuclear engineers who I love. They're wonderful. But in 10 years, that's going to be machinists and welders and plumbers and pipe fitters. And we need to retrain people to do these kinds of activities. The workforce is going to change a lot over time, and we need to make sure that it exists so that when we pop up in 10 years with what we hope is the world's best fusion reactor, we have people to work at it. We need to your earlier point, we need to continue hammering home on the public acceptance piece. Sort of the analogy of like democracy being, the worst form of government except for all the others, right? Sort of like you think about that as like nuclear power, right? It is fundamentally the most safe, like highest energy density power we need, but it can be really scary when something goes wrong, right? It's like flying in a plane is super duper safe until something goes wrong. So, we just need to make sure that we are pushing on the public acceptance and making people understand that fusion, the safety case for fusion is completely different, right? Like there is no runaway chain reactions in a fusion device, right? There's just, there's no massive exclusion zone that you need to put a 20-acre circle around your power plant in order to keep people safe, right? These things run on hydrogen and not running on uranium, plutonium. Just completely different things. But to back up to the original question is like, what does the future look like without nuclear power? I think it is very, very bleak indeed. And I think you're going to see that maybe it's not inevitable that we produce the machines that solve the problem in the United States. But I think China is going to figure out a way to do it. And China is going to dump $20 billion of government money into this problem. And we are going to be, pardon my French, but we're going to be sucking hind teat on this problem if we don't take it more seriously.
All right. So we've had a few, people bring up the question of cost of electricity, cost of these technologies. from one of our online questions, I'm going to paraphrase it a little bit, but, where are we aiming for? What does it need to be cost effective if we look at it a life cycle cost of electricity point of view? Is that an important metric? And how long will it take until we have nth of a kind? And I'm going to ask the when is fusion happening question, but how long will it take to have nth of a kind SMRs or advanced nuclear that are, cost competitive? And how long will it take to have, cost competitive fusion? And I'm going to actually make a quick point here. Senator Bradley needs to leave momentarily, so we'll say goodbye to him. If you have any closing comments you want to make, no? Okay. So if you see him sneak out, it's not an emergency happening. This was planned. But thank you for being here, Senator Bradley. But anyways, back to my question. So when are we going to have cost competitive, and what does it actually mean to be cost competitive? Is it simply life cycle cost of electricity, or are there other factors?
So I won't opine on the when will we have fusion, but I'm rooting hard. It's very soon. Relative to the cost of nuclear, right now the pro forma costs are higher than is competitive, and that is something that can be addressed. Levelized cost of electricity or life cycle cost of electricity is a handy screening measure to kind of, hey, where is this or that? But when power utilities are actually planning their systems and developing what resources they're going to add, the first early stages are levelized costs of electricity. It gets much, much more complicated from there. And you're really looking at what is going to bring marginal value to your portfolio that you already have. First and foremost, you want a power supply portfolio that is going to achieve a reliability metric. And then within that, you tend to want to minimize the cost of production. Risk is a huge, and I'm talking now not the risk of building a nuclear plant. I mean, that factors in here. But is my portfolio overly risky? Am I overly exposed to one or more particular fuel types or something? So one of the great benefits of nuclear power is it is, a diversifier relative to a portfolio heavy in gas. Renewables, solar and wind are tremendous in the sense that their price of fuel is free. And so it's kind of a hedge on fossil fuels. Uranium also doesn't correlate. So it is fairly complicated, but at the end of the day, it's really trying to understand what grid services are demanded and how can a particular reactor technology provide those. And that's where I come back to understanding what your competition is. If we could get, I'll use the levelized costs probably in the $70 a megawatt hour range, it becomes sort of a slam dunk. If your pro forma is, I can get those in 70, and maybe that's a $2.5 billion plant for an SMR, but it might actually come in at 5 or 6 billion. That's something we have to really worry about. But that's where, again, partnering to get state coalition support support across maybe several utility companies where they're sharing some of that risk, and maybe the state takes some of that, will help learning and moving forward. And I think once we can get that first build, second build, you'll start to understand what this is going to take. And I think you can get to nth of a kind pretty quickly, Paul. But getting that first one going is going to take a different way of thinking. It's not going to just be, in my opinion, hey, I'm going to go out and do this in lieu of a gas turbine or something, because the risk reward profile is just quite a bit different. But there are ways we could deal with that. That again comes back to me, in my sense, is this idea of how do we coordinate with each other and get good at this. South Korea is very good at it. China is very good at it. If you haven't seen today's or yesterday's New York Times, very interesting article about nuclear in China, I suggest take a look at it. But they are moving fast and moving forward in a big way. It can be done. It's really about how you organize, how you think about allocating risk. That may seem like sort of a Wall Streety kind of thing, but that's really what is holding us up. It's not the technical aspects of fission reactors anyway. It really comes down to the financial risk allocation and who front loads the capital to build the ecosystem of workforce development and others. That's a many hands make light work. So if we get going on that, we'll be there that much quicker.
Yeah, and I can tell you where we hope to be with Nth of a Kind, right? So you mentioned that this $70. So yeah, we're looking at our techno-economic analysis. We think we can get to about 6 cents a kilowatt hour, which would be extremely meaningful for an Nth of a Kind system. I think one thing that might be helpful to kind of frame the question is the idea of sort of like decoupling power from the fuel source, right? So you think about things in the future, nothing ever tends to get a lot cheaper. But like we just need some seawater, right? You got to process it a little bit, but we're not talking about natural gas. We're not talking about coal. We're not talking about things that are depleting resources. So, when you think about how do you build a replicable, scalable, modular machine that you can build in a factory and ship those modules on site to be built, the costs just continue going down because the cost of the fuel is never going to change. I think that, we might start at a scenario where 10 years from now, we build our first energy producing plant. And I won't even want to discuss what the cost of the power that comes out of that device might be, right? Like mostly because I don't know, but also because it's just going to be really high for a first of a kind system. I don't think that that's the kind of thing that like a customer, like, your granny's not going to want to pay for that power. But the Nth of a Kind system, I think, could get down to the single digit cents, which would be meaningful in a way that like that cost never goes up, right? You just keep building machines, and all these prices just continue to go down the longer we exist. That's the hope, at least.
Can I add one thing to his granny didn't want to pay? Again, some of these solutions, may pop up in areas that you wouldn't necessarily think about, these energy issues, they're technical kind of things, right? But we'll use your reactors here. Maybe you can get to 6 cents but the first or maybe higher, but there's a big payoff for society generations out, right? And so again, when I talk about, working at a state level, regional level or something, things like financial deferment, right? So the power company passing through right now to current customers, that's probably a hard thing, right? How do I justify asking people to do this when I've got other alternatives that are much less expensive, although they may not be as good for the environment or something, right? In utility rate making, there's sort of a concept about used and useful, right? And prudency. Well, was this a prudent investment? I could have gotten the same service for a third of the cost. You're eating that. You're not passing that on to your customers. But as we look forward and the potential here for large scale benefits, if you have, here's the cost to do the first or the second, and that learning curve comes down quickly, defer those excess power costs so that the utility isn't pushing them right out now, spread them through time. Now, how does that happen? The state or somebody can issue revenue bonds or something like that to spread that over 40, 50 years so that it's intergenerationally fair. Mechanisms like that are the kinds of things we need to think about bringing to bear.
Great. I'm glad I'm finally not the one who has to answer the question of when fusion is going to happen. So, and for those of you who aren't quick at doing the math, the 6 cents per kilowatt hour is about the $60 per megawatt hour to compare to Kevin's number, just to put you all in the same playing field. So we've had a few conversations or a few mentions of workforce. So, and I'm going to bring in supply chain more broadly. What are the challenges or opportunities, and what do you see needing to be done to make sure the workforce and the supply chain are developing not too quickly to be disappointed, not too slow to hold things back? How do we get those things happening in the right kind of lockstep?
Sure. I try to start. So, I think that we have, the biggest challenge for fusion is going to be less on the technical side and more on the people side. I think that trying to figure out how we're going to build a 1,300 person company in the state of Wisconsin is a huge challenge, right? Because we don't know what that workforce is going to look like in 10 years, right? We have an idea of what it might be, but like no one can say for certain exactly what it's going to be. So I think that one thing we try to do when we think about how to engage with communities is how do we sort of plant the seeds for what the future could look like for the workforce, like really, really early. I'm talking about like elementary school, right? Like we try to go into schools and teach kids about fusion, get them really excited about it, and open their minds to the possibilities of working in this industry. We do STEM summer camps for girls to make sure that like they feel like they're going to be part of this industry as we grow. And ideally, these people will either go to a technical college where they can come out and as like a high performance CNC machine technician, something like that. That would be really helpful. And we're also going to need some hardcore physicists, right? So we kind of have to work up and down the chain. We have to start right now. We need to talk to every different kid at every different age so that 10 years from now, someone who's 12 years old is hireable for us. And that's like an extraordinary challenge, and the return on investment for one individual that you talk to and try to get them interested in fusion is like really debatable, right? But like presumably not that great. I think that we as an industry need to do a better job of explaining to people like where we are and where we're going to be in 10 years. We need to make sure that we're aligning with technical colleges and university programs so that we're, building degree programs that are going to be, those kids are going to be hireable when they graduate from school. It's a massive challenge, but like we're trying to start this as early as humanly possible. So it's not crazy to talk to an 8-year-old about why they should be interested in fusion, because we really need that 8-year-old to be available in 15 years when we need to hire her.
So I'll build on that. I couldn't agree more. So getting to young folks when they're really young, I think is really critical, and helping them understand what is energy. It's a fascinating field. It's a great place to be. I didn't really have a good understanding of it even, when I came to Madison in grad school. I'd worked for a few years and I came then back into school. How exciting and interesting and what the opportunities are. It really is pretty amazing. I kind of look at my own family. I've got a whole passel of kids, but I got one that's an engineer. I've got one that just turned out of trade school as a welder. I've got one that's a quantitative financial analyst, and I've got one that works in science policy, right? And I think all those aspects are the workforce that we need. Certainly on the trade side, we need to really get going. And that kind of lines up with this whole notion of, hey, let's get back into manufacturing and other stuff. A lot of the manufacturing is going to be automated, high-tech machines and this and that, but those basic building trades are going to be critical there. CNC machinists, boiler makers, pipe fitters, welders, etc. Certainly a broad swath of engineering, nuclear engineering, industrial engineering, electrical, mechanical, the basic disciplines, all that is really got to get out there. So I think, getting out, helping young folks see where there is opportunity, working with communities to train folks along these lines. This is not a nuclear thing per se. We're headquartered up in La Crosse. I live up in La Crosse, and the Western Technical College just opened the Wanek Center for Innovation, which is really a dynamite thing to go check out if you haven't seen it. It's named after Ron Wanek, who is the founder of Ashley Furniture, and how they have thrived. They're worldwide, but still manufacturing up in Arcadia, Wisconsin, with a big push on automation, robotics, et cetera, right? How do you get that workforce? Well, you invest in your community with that. So in order to do that, though, where are these folks going to work, right? So it can't be, let's just focus on the workforce and then hopefully it will spontaneously come over here with building the resources. It's got to work in parallel, but it's a widespread of opportunity, a wide spectrum of opportunities that we really need to invest in, whether it's technical education, university education, and then keep the research pipelines going.
One thing in that, right? So sort of my answer to this question was very selfish and thinking about like our company and what we need, right? But like we have like a massive need for supply chain partners to help us along this journey, right? So like this is also incumbent upon the supply chain people to figure out like how they're going to staff these these projects, right? How do you like retool an entire organization that like maybe you used to focus on like shipbuilding or something like that, and now a fusion company comes to you and say, hey, like, can you build a vacuum vessel for us or whatever it is? So like there are going to be needs that the supply chain people have that like have to be filled like right now, right? Because we need to buy these long lead time item pieces of equipment. They're incredibly expensive in order to do what we have to do. And then 10 years from now, we're going to turn this thing on, right? So like this problem is started 20 years ago, and like it's going to finish in 10 years. So all the supply chain partners are going to be incredibly important to this. And yeah, it's not just us that needs lots of very highly trained people. We have to buy stuff too.
So not to cut you out, Paul, but I'll just add one thing. Yeah, again, on supply chain. If we look on the supply chain side and think about basic capabilities, I think that is really key. So something like forging, right? We do not in the United States have basically any capability to do heavy forgings. That's critical for nuclear power. It's critical for hydropower and other things. I rehabbed big hydro units. We had to have forgings done in Romania. That was then sent for intermediate machining to Brazil. And then the ultimate fine machining was done in York, Pennsylvania, right? Things like forging and other basic processes are things that from a national or a regional or a statewide basis, focusing on building those capabilities back because they're multi-purpose operations. If nuclear goes faster, that's great. If it goes slower, it can support your shipbuilding or other chemical process industries or something. So really thinking about what are those key elements that we don't want to have to depend on that will create bottlenecks. And when you have bottlenecks, and it's going to take me 9-10 years to get this SMR on, or even 6, when the virtual power plant folks can deliver me 600, 700, 800 megawatts in 9 months, that is a real problem.
Okay, I realize we haven't turned to the room here to see if there's any questions here in the room. So before I ask my next question, does anybody want to ask one here? I'll let Scott. Hands up again.
Thanks, Scott. Question probably for Kevin. You alluded to this, a question that I had a little bit. At some point, a number of utilities are going to have to get together and work on this together to share the risks, share the costs. I know Darylyn's been talking SMRs for a number of years, kind of at the forefront. How far are we from some utilities in the upper Midwest formally announcing that we're exploring this together, not necessarily putting their money down, but are we getting close to some utilities formally announcing that, hey, we're exploring this together as a partnership to manage risks and costs?
So we've had a sort of consortium of some of the upper Midwest companies that have kind of looked at this. The examination thing, I think it's less critical to have the consortium when it comes down to, okay, are we going to actually now put your money down, right? That is where it becomes critical, in my opinion. Likely, you're probably looking at a model that's going to have like a high-tech hyperscaler or something have a direct piece. They are in a speculative is probably not the right word for it. I'm not sure what's the right word, right? But they're probably open to more risk and because they have strategic positioning for them. In the utility biz, if we look at our upside downside, right? How good can it get? How bad can it get? The upside is I get a power plant that works on time, on budget, right? The upside is kind of limited. The downside is really skewed. So I think there are opportunities to work, say, with hyperscalers, and some of those are coming forward. I'd like to see, more of it. I think we all would. Utilities coming in partnerships there, less on the exploration, but the moving forward. That said, the cost tail is the potential is very skewed to the right. So we are going to need some sort of cost capping insurance. I personally believe reinsurance syndicates could work very well for that. If folks aren't familiar with reinsurance, I apologize, but they're not going to go and, underwrite building nuke policies without any actuarial data, right? So somebody in a state capacity is probably going to have to come in And once we can start getting some learning by doing, get some understanding, I think that can really foster public-private partnerships and particularly start having traditional risk mitigation, risk transfer mechanisms there. A lot of exploration going on by the individual companies. We talk with each other, but I think for all of us, again, we're kind of, I don't want to speak for them. We're excited. We see a lot of potential, but we want to make sure that we're just not setting ourselves up for something that turns out to be an expensive hole in the ground. There are ways to deal with that.
Hi, this might be more geared towards the senator who has now left, given it's maybe a bit more policy based, but there's been a lot of emphasis on the ability for nuclear to lower the rates of electricity, but this clashes with the idea of deferring the initial cost via the investment bonds. And more so, if there's anything that the pandemic has taught us, it's that a private company will take increased revenue over lowering rates. So what guarantee does the public have that the energy supply company that has a monopoly on an area will lower the rates?
So the energy company that has a monopoly franchise will be regulated, so they don't get to set their rates. That is very important. Okay. So again, coming back to a couple of concepts I mentioned, used and useful, was this prudent, right? Those are strong forcing mechanisms to have a utility company not just say, hey, I can do whatever and pass on to the customers and look at me, I'm fat, dumb, and happy, right? And for folks that, are maybe younger, they're not familiar with when we were a totally regulated business, right? But in the 70s, the 80s, the sort of hacking the rate base, as it was called, is what led to deregulating the markets and making generation competitive, right? So policy solutions are there. To your specific question around, hey, deferring the power costs, would that make it cheaper? I would argue it creates a strong potential to make that cheaper. If we have a promising technology, but the early stage risk is too much for any entity, even a sizable entity like major utility, to say, I'm going to take this on. It creates a public good problem, right? My learning disadvantages me, but the benefits accrue, right? You're going to see what happens with public goods. Now, if you move forward and you can prove this out, right? Or if you can't, you just cut and run. I don't think that would be the case, right? Yes, you have spent some money, you've deferred through time, so the impacts are not hammering anybody. But to the extent that you prove that this can work and it can move forward, and you bring that cost curve down. So say you get to where you have SMRs at $45 a megawatt hour, 4.5 cents at the bus bar levelized, right? That is more competitive than any other sort of dependable capacity and energy resource. That's a huge win. Is it worth maybe taking the risk premium, spreading it across customers across 20, 30 years to be able to get that? Because if you get that, that will make a big, big difference in rates going forward. If not, again, you have yourself with a good cut and run hedge strategy. We tried this out. It didn't work. Okay. We spread it. Again, the potential was there, not just for today's customers, but forward customers. That's the kind of thing that you have to do. It's not going to raise costs significantly, and it's in support of the potential to drop costs tremendously.
Time for one more question.
One more.
Okay, so the fact that Senator Bradley's committee was called Utilities, Technology, and Tourism is, to me, one of the most serendipitously magical things I've heard in a long time. So first generation nuclear plants, right? They're big, imposing technology. I think were built out of a military culture that was not very welcoming, right? And I don't think that people generally know what happens in a nuclear plant, but we make it scary to them. So do you think there is potential, as people who build, run, operate this, to combine the elements of smart tourism, right, in design to make this technology more welcoming?
I might need you to clarify the question a little bit.
So for instance, in I forget which country, they had to build a trash heap, right? They turned it into a ski hill, right? You could, there are nuclear plants in the country that make it movie night off of the walls, right? Instead of fortress nuclear, you could make it something that the kids just want to drive by and see,
Yep.
right? And change the way we think about it. And I'm just curious, to you, is it worth the extra cost?
Absolutely. Yeah. And what's interesting about fusion plants and the difference in the safety case between fission and fusion is this notion that I talked about earlier of the exclusion zone, right? So think about a place like Singapore, right? So Singapore, not a good fit for fission power because the exclusion zone is bigger than the island, right? Like you just cannot build fission plants there. They're just not feasible. But a fusion plant, the exclusion zone is like, it's like a fence, right? Like it's not a big deal because the worst thing that can happen with one of these plants is that something goes wrong. It just shuts down, right? So imagine like spinning a basketball on your finger. It's hard to get it going, right? And then, but as soon as it falls off your finger, it just stops, right? So fusion is just like one of these things that you can get it going, great. It's harder to get it going, but it's easy to stop it. It's the opposite of fission. So because of that, we don't have these massive exclusion zones around these power plants. So you could put it in a prairie, right? You could have walking paths around it. There can be lakes. There's no impact on the water around it. So I don't see why you couldn't have a fusion device in a city park, right? Like these are things that you could easily do with these devices that you couldn't do with fission.
Yeah, it's a great question. And I think you're right. I mean, having been in the nuclear industry early in my career, kind of went to a different part of the biz and now back. Yeah, nuclear, through my experiences, whereas pretty much, the less said about us, the better. People shouldn't know we're even here, right? And certainly nuclear safety is paramount and all that. You don't want anything like that. But actually helping people learn and understand, I think, is critical. And I'll point to some other energy generation technologies that do a great job on this. So the company I led back in Washington and a sister company just up the river, Chelan PUD, Grant PUD. We built museums and visitor centers around our big gigawatt scale dams to teach people about hydropower, about the heritage of the development of the dams, what it meant. For my old company, we had some impacts on some of the Native American tribes. We built a cultural center, Smithsonian Quality there. We built all kinds of signage and other stuff. We ran golf courses and all kinds of stuff, right? To flow those benefits back so people could see, come learn about this, get out in the schools, get out to service clubs. But from a tourism perspective, yes, that can really work. Another great example in the nuclear industry is the National Park Service's Nuclear Triad. If folks are not aware about it, you can go out to Richland, Washington and go to the B reactor. That's the one that made the plutonium for the Nagasaki, right? You can actually go out to that reactor. It is phenomenal. But even if you couldn't get to that site in Richland at the edge of town, which is in town, it's a big town, there is a tremendous interpretive visitor center that you could spend hours and hours. They have it at Los Alamos over at Oak Ridge, right? So this can be done. Grand Coulee Dam for years has put a laser light show on every night. Grand Coulee Dam, if folks don't know, biggest thing made by a man, 6,500 megawatt hydro plant up in northern Washington. They bring in thousands of people all the time. And with that, there is a true and beneficial message about the pluses and minuses of hydropower, but the pluses are really outweigh the minuses. So I think it's something that isn't just an option, it's something that must be done.
All right, I think we're reaching near the end here. So thanks to everyone for being here. I'm going to give an opportunity for our speakers to make any final comments they want. If there's something they've been sitting on that they wish they'd said earlier. So I'll pass it down and let them make some final remarks, and then we'll wrap up.
Sure. So this actually goes back to the most recent question. So, when we think about where we want to be as a company in 10 years. We know that we have to engage with the public on things like the safety case, things like, tritium in the water, right? Like things that could be potentially scary to people. And we know we need to start those conversations now, because the worst thing that we could do is just kind of head in the lab, go underground for 10 years, kind of beaver away at this problem and emerge with the best technological solution you could possibly imagine. And then we come and say, hey, who wants this thing? And everybody's like, I do not want this in my backyard, right? Because I don't understand it, because you didn't take the time to explain to me why this is good or what I need to be concerned about, right? So, we welcome these conversations about what are the possible problems. Like, we actively seek out people who do not think that what we're doing is a good idea, and and we're happy to have you come tell us this is stupid, right? Like, that's fine with us. We want to have those conversations because we need to know where those pockets of opposition are going to be, so that 10 years from now, when we have this device, you want it in your neighborhood.
Yeah, so I'll just say I thank everybody for the opportunity to be here, and my behalf and Dairyland's really appreciate your interest and opportunities. I agree with what Rob said. I guess the one little thing I would add to that is when you're out engaging with the public or out in the schools and that sort of thing, I think bringing in a dimension of helping the general public understand relative risks, not in a wonky way, but helping them do that. I understand fully as an ex-PRA guy that, trying to communicate risk and probability to folks can be a challenge. But when we see so often in various energy technologies, but nuclear for sure, misunderstanding of the relative risks, et cetera, I think that's a real opportunity along with the tourism and other things, and appreciate the opportunity to speak to y'all.
All right. Well, thanks again to our speakers. Thanks to all of you who joined online. There were some great questions posed there we didn't get a chance to answer. So hopefully you can find another venue to ask those questions and have them answered. Thanks for everyone being here, and I'll pass it on to Scott for final points.
All right. Yeah. And thank you, Paul, for moderating today. And let's give all of our panelists a round of applause. And we are recording this, so it'll be posted to our YouTube in a few days. So feel free to share the recording with your colleagues. Reminder, we have our next forum in 2 weeks, so 2 weeks from today on November 11th. And then finally, folks who are online, you'll get a survey once you close out of the meeting. For those in the room, I'll put this QR code up here. If you could answer a very, very short survey to let us know how this forum went and any ideas you have for future forums, we'd really appreciate it. So thank you all for coming, and hope to see you all in 2 weeks.